In this brief demo, we will work with LabVIEW and the Digital Filter Design Toolkit to design a digital filter and then save the result of the design, a set of coefficients, off to a text file. Let's start by opening a blank VI. On our VI, we'll move over to the block diagram, which is the graphical code, and we'll locate the Digital Filter Design Toolkit palette. From the Digital Filter Design Toolkit palette, we'll choose the Filter Design subpalette and drop an express VI for classical filter design. This express VI offers a configuration-based interface with interactive controls and indicators that update as you make the changes to the parameters. And on this interface, we were able to select the filter type, low pass, high pass, band stop, as well as the parameters associated with the filter. For instance, the sampling frequency, the passband edge frequency, the passband ripple, stop band edge frequency, and the stop band attenuation. For this filter, we're going to design a low pass filter with a passband edge frequency of 200 Hz and a stop band edge frequency of 400 Hz. And notice that as I change the parameters, you can see here the magnitude response graph updates to reflect those changes. I can enter the parameters that I want to work with using numbers on the left hand side here, as I've done, or I can move the cursors on the graph here to change the parameters graphically. So I'm able to adjust the ripple, for instance, and the passband edge frequency and the stop band edge frequency. Also notice that as I update my design, the poles and zeros associated with the design are updated on the top half of the Z-plane plot here, with the zeros marked off as the little red circles and the poles marked off as the blue X's. So I've changed a few parameters. I've settled on a filter design. Let's say I want to choose a different design method. I've got several available here for me. I can choose Butterworth, inverse Chebyshev, or equal ripple FIR, often known as the Remez exchange method of filter design. And let's go ahead and use the equal ripple FIR for a FIR type filter. And you notice that as I was choosing the filter design too, the design results were updating, and you can see the position of all the zeros on the pole zero plot, the upper Z-plane, as well as the required filter order. Again, as I make a change, you'll see the filter order change as well as the position of the zeros in this case. So when I click OK here, my dialog box closes, and now I have an icon that represents my designed filter. And the designed filter is actually available as a wire that I can run from this output filter out. I'm now basically ready to work with my design. So there are a number of different things I could possibly do with my design. And for instance, I could apply some further analysis, or I could convert the design to a fixed point implementation and then continue with the design for a fixed point implementation. I could also apply my design. For instance, I could apply it to a test signal. In this demo, what I'm going to do is basically export my design as a text file. So to do that, I can work with one of the other tools available in the Digital Filter Design Toolkit, available from the Utilities subpalette here. In the Utilities subpalette, there is a DFD Save to Text file icon, which I'll drop a copy of that down, hold it close to my icon for my filter design here, the equal ripple FIR low pass filter design, and notice some wires have automatically appeared, and these wires basically, when I run my LabVIEW application to actually perform the design, these wires will actually represent the filter design and basically tell the LabVIEW application to pass the filter design that I've created here over to this second VI here, which is going to save that design off to a text file. So with this in place, I can go ahead and run my VI to go ahead and implement the design. Notice that when I do, I get a select file path dialog box here, where I can go ahead and choose a file name for my exported filter coefficients. I'll go ahead and save these in my documents folder for my test filter, and this will save the design off as an XML file that I can later load up using a text editor. So I've just saved my filter coefficients off to a text file. Let me go ahead and open up a text editor and load those coefficients up into this text editor to see what the resulting file look like. I'll go ahead and choose open in this freeware text editor called site. open up the My Documents folder where I had saved my test filter.xml and load it up. And you can see here that LabVIEW has automatically created for me a XML file that has all of my information about my filter. For instance, the order here is order 22. My structure is referenced here, as well as the FIR coefficients, and these are the numbers that are actually designed. And with this particular freeware text editor, I'm able to collapse and open the different sections of my XML file, so you can see that lower down in the, or further down in the file, I have my zero, pole, and gain. The locations of the zeros in this case are listed out here, as well as the desired gain. So once I have these coefficients, you can imagine the sky's the limit for the design. I could cut and paste these into my source code for actually implementing a filter, or I could plug these into other applications for actual application. Of course, LabVIEW has a number of alternatives for actually applying the filter, including code generation. This is just one of these alternatives.